Now we're going to take a look at condensing log expressions. So we have log of 9 plus 3 log of 2 minus log of 3. So again, looking at our properties of logarithms. So now we're going to condense. We want them as a single log, so I shouldn't see them all separated. It condenses into a single one, just like we have here. Okay, so our goal is to get it all down to this where we have a single log. And so we have to look at our properties of logarithms again. So we're going to start on this side, and then we're going to end up with a single log here. So if they're adding, then you're going to combine it and make those values multiply. If you're subtracting, then you combine the log, and now it's dividing. And then if it's raised to a power, then you know you're going to move it to the exponent position. Now what we're going to end up doing is we're going to start here with the powers, because that's the fastest thing to do, and then we'll do the other things. So let's try this out. So we have log of 9 plus 3 log of 2 minus log of 3. So the first thing I notice is this number 3 here, and that goes as the exponent. So let's start with that. Log of 9 plus log of 2 raised to the third power minus log of 3. Now I just want to remind you, anything with a negative, that's going to be in the denominator. So you could always rewrite it if the negatives are not grouped together. You could group them together in one spot to help you out. Now let's continue this. Let's do the addition first. We have log of 9 plus log of 2 to the third power. So this is adding. What that means is I can take these values here, and then I'm going to multiply them. So notice, I'm going to write a single log and then 9 times 2 cubed, and I still have this minus log of 3. So the minus means that this value is going to be in the denominator. So let's condense further. This becomes log of 9 times 2 to the third power and divided by 3. So what I want you to notice again is that there are no extra logs. You cannot write this as log of 9 times 2 cubed over log of 3. That is something completely different. So do not write that. That is not correct. Okay, I should never see that. That is another operation for another time. All right, so now looking at these numbers here, now that they're numbers, we can simplify it. So before you grab your calculator, let's see if we can simplify this. So we have 9 times 2 cubed over 3. Now 3 can go into 9, so 3 goes into 3 once, 3 goes into 9 3 times. And so now we can simplify this. So this is log of 3 times 2 times 2 times 2 over 1. So this is 3 times 8. 3 times 8 is 24. So the final answer is log of 24. So try these two examples out, number 7 and number 8. Condensing the logs. All right, if you tried it out, you should have gotten log of x over 9. You're subtracting, so you just divide those values. For this one, so first I'm going to move this to the exponent position. So this is natural log of 4 plus natural log of 3 cubed minus natural log of 12. Then this is adding, so I'm going to multiply those together. Natural log of 4 times 3 cubed, and then minus natural log of 12. The minus means that this is going to be in the denominator. So now, to condense this even further, this is natural log of 4 times 3 to the third divided by 12. Okay, so it's only the number that is dividing. It should not go over under that entire natural log. So just formatting things. And then so now we want to simplify. And so one way to do this is that 12 is really 4 times 3. Okay, you can always do it in your calculator too. But if you didn't have a calculator, this is nicer. So 12 is really 4 times 3. I like that because I see 4 and 3 at the top. So the 4's cancel. 3 cubed over 3, that's just going to be 3 squared, right? So I just subtract my exponents. So notice that it's just natural log of 3 squared or natural log of 9. So try out the more practice on condensing log expressions. So like letter E, for example, that's really challenging. So that's like if you're like, hey, I want to do something really tough. Try this out. Remember what I said about negative exponents, and that might help you out a little bit for that example. Letter D as a hint, when I move this to the top, what does 27 to the 1/3 mean? I hope you remember from chapter 5 that you can simplify that to help you out. Okay, so try these out. All right, here are all the answers. So letter A, you should have gotten log base 2 of 24 because you multiplied the 3 and the 8. It's now a single log. Letter B, you move the 2 here to the exponent position, so that's log base 5 of 5 squared. And then, so you notice you have log base 5 of 4 divided by 5 squared, and then that's really 4 over 25. So don't simplify, just condense. Then the letter C, you move this 3 to the exponent position. Notice that I had to put parentheses because it does belong to the 6 and the x. And then, so therefore, this becomes 6 to the third power, which is 216, and x to the third, plus 4, natural log of 4y. Then you condense further and you multiply those together. So 216 times 4 gives you 864 x cubed y. Letter D, I talked about this. So the 1/3 goes to the top as 1/3. 27 to the 1/3, remember, that is just 3. So it's cube root of 27, right? Cube root of 27, that is 3 times 3 times 3. And so that's why this changes to a 3 here. Then the 625 minus log base 2 of 125 plus log base 2 of 3. So the positives will multiply 625 times 3. Then the 125 goes in the denominator position. Okay, so now it's a single log, and then you evaluate the numbers. So 625 times 3 divided by 125 gives you log base 2 of 15. Now looking at letter E, so anything with a negative is going to go in the denominator. So the 6 and the 2y go in the denominator. Then you have the 2 log 6 of 3x, and so this 2, that's the exponent, so it goes up there. It belongs to the 3 and the x. So therefore, this is 9x squared in the top, and then 6 times 2 is 12y. And then you reduce. So you can divide by 3, and so this is the final answer. Again, a really good challenging problem, and so I hope this helped you out.